안녕하십니까, 니콜라스입니다. Today I'm going to talk about the top 5 programming myths that stop people from learning how to program and that make junior developers feel like they are not good enough. I used to believe all these myths before and it really slowed my progress. The first one is everybody can learn to program. This one, it's a lie. This one is a lie that many companies tell you because they want to sell you courses and books and bootcamps and videos, and it's not true. People keep saying that everybody can program because programming is easy and fun and that anybody can do it, when it's not true. Not everybody can do that. It's not going to be enjoyable for everybody and it's not going to be a career path for everybody. As a teacher, I can honestly tell you that there are some people that are just not good or they are just not made for programming, just like I am not made to dance ballet. Some people are just different and that's okay. Saying that everybody can be a programmer is like saying that anybody can be a painter. Now, we can all take paint and put it on the canvas, but that doesn't mean that we are going to be good at mixing colors or at proportions or at shadows, and most of us are not going to enjoy painting. I fucking hate painting. You need to enjoy logical thinking and problem solving, and also you need to be okay with the fact that most of the time spent programming is frustrating, is lonely, not socializing, in front of a computer, feeling like you are an idiot because your code doesn't work at 3 a.m. in the morning. This is why if you ask programmers if they really enjoy programming per se, they will say no. Programming per se, it's very, very frustrating, boring, annoying, whatever you want to call it. But what you will see is that programmers enjoy programming because of the result, because of what happens when you finish, what happens when you push through that frustration and your code is finally there. Programming is not for everyone. Programming can be painful, can be frustrating. Everybody should know this, but also it's worth it. Number 2, programming is memorization. Beginners approach programming the same way that they approach studying for an exam in college, where it's all about remembering but not understanding. This is especially true in Korea, where everything is focused on the result on the exam rather than on the process. Programming is the opposite. First, you need to understand the concepts and then you get to remember them. It is not about memorization whatsoever. To make a great piece of software, you do not need to remember all the keywords on the programming language or whatever you're using. You need to logically understand the problem that you need to solve and what tools you have available, so then you can make use of the tools to fix it. Most programmers do not remember anything. Most programmers Google at all times. Senior programmers are not seniors because they remember everything and never use Google. Senior programmers code less and make more money than juniors because they just have a better view and understanding of all the systems and all the landscapes of the software development world. If you want to be a good programmer, don't try to memorize, try to gain understanding first. Number 3 is you gotta be a genius to be a programmer. This one is a big one because of what we see on the movies most of the time. It's some like kind of wizard kid that is on the screen typing really fast, never making any mistakes and just hacking into the White House in the United States. Now this is not what a good programmer is or what a good hacker even is. This myth is the one that hits hardest for junior programmers that feel like they are not good enough. They don't feel ready to ask for a job, so they keep studying and studying and studying and studying. And this especially happens in Korea, where everyone wants to be at the top and being at the middle is not good enough. And actually, you don't need to be a genius to program. They are just okay programmers. They are the average. They are good enough. Decent, good enough, okay programmer is what most of us are. You don't have to be a genius programmer to be able to get a job, to start your own company. You can just be good enough, and that is okay in the programming world. Number 4 is programmers are talented. If you know how to program, it's because you have a talent that God gave you or something. Now, I'm a firm believer that discipline beats talent. Sure, maybe there are some people that are better at computers. There are some people that maybe will understand something like distributed cloud database systems faster if I explain to them. But programming is not a game of talent. Programming is a game of persistence. Programming is basically saying, okay, I'm not gonna go to sleep until I fix this function. I am going to find this bug. I'm not gonna get angry and I'm going to read and do everything again. What it takes to be a programmer is not talent. What it takes to be a programmer is not giving up. Programming is a constant fight with the machine. That's how you win. You win by not giving up. You don't win with talent. If you have focus, if you are disciplined, if you are patient, you are going to be a better programmer than somebody else that has a talent but cannot focus. Number 5, you need to be good at math. The reason why I put this one here is because many people make it look like math and being good at math is a requirement to learn to program, and that is not true. Now, it's not a requirement, but it helps. If you don't like math, can you still learn to program? Yes. What can you do if you suck at math? You can do websites, frontends, backends, databases, full stack. You can do iOS apps, Android apps, even maybe some video games as well. But you're going to have a ceiling over your head. You're going to have some limits. For example, you won't be able to do something like a physics engine or create machine learning models or work with something like self-driving cars or maybe even some stock exchange automation. Now, if you want to do these things, you are going to need math. If you want to do the sort of things that Tony Stark would do, you need math. I suck at math and I'm happy that I'm never going to build a self-driving car. I don't care about building a self-driving car, so I'm happy. Done. Alright, that was the top 5 myths. Programming is not for everyone. Programming is not memorization. Not only geniuses can program. Programming is not a talent game. And if you suck at math, you can still be a programmer. Thank you so much for watching this video. Thank you so much for listening to me, for leaving comments, for leaving a like. Let me know what you think is the myth number 6 on the comments. We're so close to 100K. Thank you so much for your support. You know I 사랑해요 very, very, very much. And as always, 감사합니다. 네. 안녕하세요. Which programming language should I start with? Now this question is very hard to answer correctly. The reason why is because when you ask me that question, I don't know you. I don't know what you want. I don't know what you want to build. So if I tell you, oh, just learn Python, HTML, CSS, I will be robbing you of an explanation that you deserve and a background that you need to understand. I'm going to answer you with giving you 5 programming languages, the more popular ones, why are they used, if you learn them, where are you gonna go? The first one we start with is C and C++. C is a programming language designed for a very, very low level performance. Very, 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 very close to the machine. So for example, you can use C to program air cons or smart TVs or smart fridges, stuff like that. Something that has a little bit of, yes, programming, but it doesn't have lots of memory. Also, if you learn C and C++, most likely you're also going to find a job in those big companies or enterprises that have and make softwares that require performance. For example, you're going to end up working in a project like Photoshop or Premiere Pro, like in a company like Adobe, that you have to make software that really needs performance. Next programming language, Java. Java is very popular in Korea, and most of the time Java is very popular in corporations, government, banks, and all that stuff. Nowadays is used to build enterprise web applications. If you learn Java, you're 100% gonna get a job. There's many jobs for Java. They are not most of the time in very fast moving startups. Java is usually used by enterprise, as I said, or when you need to integrate with older legacy systems. So some banks are in Java, most governments are in Java. Company that integrates with these kind of services, then you're gonna need Java. Also, if you learn Java, you are going to be able to program Android applications. So if you want to be like an enterprise developer, you know that you have a job and to have a safe job in an environment that doesn't move as fast as, for example, front-end development, then Java is for you. Also, if you want to be an Android developer 100% and you love Android, then Java is the place for you. Next one, Python. I think the easiest choice for a beginner, and the reason why I say this is because Python is very, 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 very multi-purpose. For example, in Python, you can find how to hack computers, which is how I learned. Also with Python, you can do machine learning. Also with Python, you can do data science. Also in Python, you can do data visualization. Also with Python, you can do scraping the internet. Also, you can build websites. There's many, as you can see, you can do many, many, many things. Beginner-friendly language. It's not as ugly as Java, and it's not as ugly as C. You need to remember that the closer the language is to the system, the lower level, the more ugly it is. Python is a very pretty language to read, and that's why beginners like it so much, because it doesn't scare you at the beginning like C. If you see C, oh my god, what the... Okay. JavaScript, but let's make one programming language. Let's call it HTML, CSS, and JavaScript. If you want to build websites, and that is the main focus of what you want to learn to program, then go for HTML, CSS, and JavaScript. That is how you start making websites. Some people will tell you, oh, if you want to make a website, then go for Python because Python makes websites as well. Yes, you can make a website with Python. The difference is that with HTML, CSS, and JavaScript, you learn by building something that is visually attractive for you. And also you learn how the web works from the ground up, from nothing to everything. So when you want to become a web developer, and if that's what you want to do, then HTML, CSS, and JavaScript. Now also, if you learn JavaScript and you like it a lot, you're going to be able to build many dynamic websites. You can also make some iOS and Android applications. You can also program the backend. Now JavaScript is also kind of multi-purpose like Python is, but JavaScript is very old and PHP is to build backends. You can build backends with PHP, and PHP runs everywhere. Most of the internet runs on PHP. Why? Because there is this thing called WordPress. And WordPress runs with PHP, and many websites use WordPress for many, many, many things. Also, PHP is stable, the community is big. I don't usually use it that much. I learned it before, but for me, it's not my thing. I prefer Python or Node.js. But also, if you learn PHP and you want to be able to do stuff for WordPress, if you want to be able to do stuff for things like Magento or Drupal, stuff like that, like content management systems, then PHP is your guy. Whew. All right, my people, that's it. So now is your turn. Ask yourself the question, what do you want to build? And then choose, all right? Start with why first, know yourself, and then all the answers will be in front of you. Thank you for watching. Let me know what you think about this video. I know many people are gonna disagree, many people are gonna agree. Please comment and ask me more questions. I'm very, very happy that I'm getting more and more questions every day. No question is stupid. All questions I love. Thank you again for watching. Don't forget to be happy, eat kimchi, and samgyeopsal. Bye-bye. 안녕하십니까? 니콜라스입니다. Today, I want to talk to you about the process that I follow when I'm learning a new programming language. And that's because nowadays I'm very interested in Go, and many people have been asking me, how did I learn Go? Did I take a course? Did I watch a video? Did I read a book? What did I do? So that's what I want to talk about on this video. And this process that I'm going to describe has helped me learn many languages and many frameworks over the years. So that's what I want to share that with you. Now, first we need to answer the question, why should you, as a developer that already have a job as a developer, why should you learn a new language? What's the point? Well, if you are a developer, let's say you're a Python developer, and you learn a new language, what's going to happen is that your Python code is going to improve. For example, when I was writing JavaScript most of the time, and then I went to learn Haskell, and I came back from learning Haskell, my JavaScript code was so much better because of that. Because learning Haskell, I learned new ways of doing things. I learned new philosophies. I learned how to structure the code in a different way because of the Haskell rules. And then when I brought that into JavaScript, my code was way better because of that. So when you learn any new programming language, any new technology, Those things have new philosophies, new patterns, new structures, new whatever, and that helps you when you bring those concepts back to your main programming language. So if you're a Python developer and you go and learn Rust, you might find something that you like from Rust and that you can bring into Python, and that means that you will become just a better developer overall. So the first thing I do when I'm learning a new language is I go to the documentation. On the documentation, I find out why did they create the language, what is the philosophy of the language, what is the best use case, who is using the language, and also the community, the creators, all that is there. So I go immediately to the documentation. Then I try to understand and remember the syntax of the language. So I need to find out if the language has parentheses or square brackets or curly braces, comma, no comma, all that. I get that done as fast as I can. Then what I do is I try to find equivalencies. Equivalencies, taking knowledge that you already know on your main language and trying to take that into your new language. So for example, this is how you make a function on Python. How do you make a function on Go? I try to find that out. This is a variable on Python. How do I make a variable in Go? This is how you make a conditional in Python. How do I make a conditional in Go? I try to make these associations, these analogies, because the brain works so much better when learning something that is related to what you already know. Once I'm done with the equivalencies, function, function, variable, variable, object, object, once I have that in my brain, I immediately go and start writing code. The most important thing is that you need to write code as fast as possible. Don't waste time looking at tutorials. Don't waste time reading more about the language. Write code. Now, what code do I write? I don't write amazing things at the beginning. I just write the equivalencies. I create a variable on that language. I create a function on that language. I create a conditional, a loop, all that on the language. So I'm familiar with writing on the new syntax. Once I'm done writing all those old concepts in a new language, what I do is I go for tutorials. The thing with tutorials is I felt like I was just copying code from the songs and name. I didn't feel like I learned anything. I just felt like I was just copy-pasting code. So now what I do instead is that I take on a tutorial or an open source project or whatever, break it down and then put it back together. That's what I do now. I remove one part, remove another part, and just break it down, understanding what happened, and then I try to put it in together again. These kind of things help me understand more because now it feels like the code is mine. Because it feels like I can take it apart and I can put it back in together. And then, once I'm done breaking and fixing other people's code, what I do is I start writing my own code. I start creating my own project. And this is when beginners have a problem, and is that they start with projects that they have never built before. So they say, okay, I'm learning Go, I want to make a chatbot. And then you tell, okay, have you made a chatbot before? No. And that's a problem. When you want to make a project on a new programming language, and also you have never made that project before, you have to find out two things. First, you have to figure out how to make the project logically. And then you have to write that down on a new programming language, and that is an impossible task. What I do instead is that I take projects that I already built and I turn them into the new programming language, but the logic will be the same. And this allows me to focus on learning the new programming language instead of also having to figure out the logic of my new project. I take a to-do list that I built on JavaScript and I make a to-do list in React. Then I take a to-do list in React and I make a to-do list on Vue. So for example, and by the way, we are launching a new course today of Go. In the new Go course, what I do is that I take a Python project that I built before and I turn it into Go. So you build things that you already know on a language that you don't know. And that's the key for me. Thank you for watching. That's it for this video. I hope that you can get any of this advice and I hope that I can help you learn programming languages faster. Like I said, we are launching the Go course today. It's finally here. So go and check it out. I know many people have waited for that. So I really try my best to make a very nice, sexy, free course. So thank you so much for your support. It's finally here. I delivered. I kept my word. I'm sorry it was so late, but I've been very busy. But there it is. So go and check it out. Click on the link on the description. And as always, don't forget to be happy. Don't forget to eat kimchi. Don't forget to be nice to people today. take care of the virus, wear your mask, wash your hands, and as always, 사랑해요, 감사합니다, bye bye. 안녕하십니까, 니콜라스입니다. Today we are going to talk about why Java is named Java, why Ruby is named Ruby, why Python is named Python. Let's get started with Java. Java was first going to be called Oak, like the tree, because that tree was growing outside of the offices of one of the designers of Java. The problem was that they couldn't name it Oak because it was already trademarked. There was already a company with that name. So the lawyers came back to the team and they told them to come up with a new name.
He fucked up.
And what the team was is that they went into a room and they started to do brainstorming of some names. And some of the options that they got were, for example, DNA or Silk or WRL, which means Web Runner Language. And thankfully, they arrived to the name Java. Java is also a kind of coffee, and it's also an island on Indonesia. So that's why you see that the logo of Java is like a hot cup of coffee. Then we got a programming language called Kotlin. Kotlin is directly inspired by Java and is actually like an improvement of Java. Kotlin is made by a company called JetBrains. That company is a Russian company. And because Java is also an island on Indonesia, JetBrains named their programming language after a Russian island. Then we have JavaScript. JavaScript was first called Mocha, like the coffee plus chocolate preparation. But then they switched from Mocha to LiveScript. And at that point in time, Java was super popular. So what they wanted to do was like a marketing trick, and they changed the name LiveScript to JavaScript, hoping that people thought that JavaScript was going to complement Java, and they just wanted developers to basically be interested in JavaScript. And it looks like it worked because now JavaScript is one of the most popular languages. C was named after a programming language called B, because many of the things that B had, C got influenced by. Then we got C++. On the programming word, plus means increment. So basically, it's like an increment of C. So C++ means like C plus 1. And then we got C#. On the music word, when you play a note and you put the sharp, that also means an increment on the note. It should be played a tone higher. So on the music word, sharp is an increment. On the programming word, plus is an increment. And if you look at it, C# is basically C with 4 plus. Ruby is a programming language created by an Ilbon Saram, and this programming language was directly inspired by Perl. Perl is like a precious stone, and it's also another programming language. So what the creator of Ruby wanted to do was also name his language like a precious stone, so he chose Ruby. Python was named after a comedy show called Monty Python. People think that Python was named after a snake because the creator of Python loves snakes. It's not true. The creator of Python loved a comedy show called Monty Python. And now, if you're wondering, Go was created by Google, so that's why we have the Go part. The name of the mascot of Go is, and he is an animal called Gopper. And Rust was also named after a fungus because the designer of Rust kind of liked those sort of organisms, so that's why he made it. Nothing much on that name, not much story behind it. That's it for this video. Thank you so much for watching. Let me know on the comments, if you made a programming language, what name would you choose? Thank you for watching again. Don't forget to be happy. Don't forget to eat kimchi. 사랑해요 and 감사합니다. Bye bye. Mwah. 안녕하십니까, 니콜라스입니다. Today we're going to talk about the difference between C, C++ and C#, because they share the same C on the name, so sometimes we can get confused. So, C is a language that was created 47 years ago. It's a very long time ago. C has influenced languages such as Java, JavaScript, Python, PHP, Go, among many others. So it's seen as a very important language in the history of computer programming. C was created, as I said, 47 years ago. That means that back then the computers weren't so fast as they are right now. So C is very good at working on machines that don't have a lot of resources and being as close to the hardware as possible. For example, things that are made on C, the Mars rover Curiosity, that thing that was sent to space, to Mars, that landed in Mars, that has been moving around, taking photos of Mars and sending them back to NASA over satellite and the space or whatever that is. That thing is programmed in 2.5 million lines of C code. That is just raw C code, because the Mars rover, that little tiny robot, not little, but that robot doesn't have a lot of memory, doesn't have a lot of processing power, so we need as much speed as we can in as little space as possible. That is C. Now, what is C++? C++ is just like C, but with classes. And even the creator of C++ says that C is obsolete. When he created C++, he intended C++ to be like a superset of C. A superset is a language that extends another language. So for example, JavaScript and TypeScript. TypeScript extends JavaScript because it adds types. JavaScript doesn't have types. TypeScript is just like JavaScript, but it has a new addition, an extension, because it has types. C++ and C was supposed to be seen as a C with classes, because C does not support classes. Object-oriented programming, that is very, very important when you are organizing large code bases. This is what the creator of C++ says. The creator of C++ says that he intended C++ to be the replacement of C, and that they should have been just one language altogether. Unification, because they are so similar, except that the C++ has classes, among other details. Now, what is programmed on C++? I don't think that there is a difference in speed whatsoever, and there is not a difference in how close you can be on the hardware, but people sometimes choose C++ because they enjoy the object-oriented programming. Now, C#. C# is a whole different beast. C# is more similar to Java than it is to C++. C# is like the Java of Microsoft. It's a programming language that was created for the enterprise applications. Microsoft spent thousands of dollars and hours making this language because C# works on the .NET ecosystem. Java and Oracle, that's one thing. C# and .NET, that's the other thing. There's like two teams for the corporate and the enterprise. In Korea, I've seen that Java rules the most, but outside of Korea, mostly in the US and in Europe, C# and .NET, they rule the most. Also, C# is very powerful. You can make backends, you can make frontends, you can make iOS applications, and nowadays C# has seen a very high increase in usage because of Unity 3D. In C#, if you learn C#, you can make video games for Xbox, PlayStation, computer, iOS, Android, and even web with Unity 3D. Unity 3D is a video game engine. So the thing is that C# is not as fast as C++, because on C# we don't do stuff manually. The compiler and the program help us doing some stuff. On C++ and on C, we have to do things manually because C is more of a lower level language. So people say that on C++ the computer runs fast, and on C# the developer runs fast. I think C# is a language where many developers are very satisfied with it because it just has a lot of developer speed. You can do lots of stuff and you don't have to do things manually as with C++. C# is more similar to Java. So for example, if you know JavaScript, TypeScript, or Java, you can go into C# really, really quickly, and it will take you maybe 1 or 2 weeks to get ready and go for it. In my case, I program on C# because I like to make stuff in Unity 3D. So that's why I use C#. I never work with Microsoft, any kind of Microsoft enterprise, but it's a very good career choice to learn C# if you want to work with the enterprise and the .NET ecosystem. Alright, so that's it. In very small systems, speed. C# is more of an enterprise thing. C# looks more like Java than it looks like C, and it's enterprise. Developer speed on C# is higher. Computer speed on C and C++ is higher. So there are different beasts for different things. Most companies use C# or Java, and then when they need actual speed, they go for C or C++. Thank you for watching. Let me know what you think of this video. I really, really appreciate all your support and all your comments. I saranghayo very much. And that's it. See you on the next one. Don't forget to be happy today. Smile and eat kimchi. Bye bye. 감사합니다. 안녕하십니까. On this video, I'm going to talk about why Python is such a popular programming language, what are the best 3 uses of Python, and how you can start learning it. This year, Python passed Java on the Stack Overflow Developers Survey as the most popular programming language. Last year, it passed C#, and the year before that, it passed PHP. Python has been growing exponentially and really fast these last maybe 4 to 5 years. But why? Python is not popular only because of one reason. Python is popular because of a combination of many reasons. The first one is that Python code looks almost like English code. It's very close to the human language. Even if you don't know any computer science, even if you don't know how to program, but you read some Python code, you will chances are be able to understand what's going on because it really looks like almost like just human normal language. And that's something that developers that are starting love, and it's something that developers that are experienced also love. Another reason why it's so popular is because Python keeps your options open. It doesn't put you on any box. For example, if you don't know what you want to do, maybe you want to try web development, maybe you want to try AI, maybe you want to try data science but you don't know, maybe you want to do some security and hacking and all that, Python is the perfect language for a person like that because you don't have to go into a box of backend developer, AI developer, machine learning developer. You do not have to do that because if you learn Python, you can move between all those disciplines as much as you want without having to learn a new language. So if you're having a hard time choosing which area of technology you want to work, learning Python is just going to be the perfect choice because it will allow you to just try a little bit, see if you like it, and if you don't, move on without learning another programming language. And that brings me to my reason number 3. The community in Python is unbelievably awesome. It's very big and very diverse because we have people from everywhere on the industry. We have people that are machine learning engineers, we have web developers, we have hackers, we have data scientists, we have mathematicians, we have finance. We have so many people on this community and they are all coming with their own tools, with their own open source. So there are more tutorials, there are more courses, there are more videos, there are more questions, there are more answers. And it's just when you're starting as a beginner, seeing such huge community will help you a lot. With Python, you can do almost anything because it's a multi-purpose programming language. But the 3 things where Python is used the most is on web development, AI, machine learning, and data science, and scripting. So web development with Python, you can make a backend for an application, you can make an API, you can make a whole website using Python. For example, Instagram uses Python, Pinterest uses Python, Reddit uses Python on their backend. The second one is machine learning. Many people are making amazing libraries for machine learning, such as, for example, Google is giving us TensorFlow. We also have Keras, we also have Panda. We have so many libraries for machine learning that if you want to get into machine learning, that is the way. Python is really used by the industry into train models, supervised learning, unsupervised learning, all that, it's on Python. Now, the third use of Python is scripting. And scripting basically means automating the boring stuff. For example, if you're an office worker and you need to maybe change the name of 1,000 PDFs, you can make a simple Python script that will do that in 1 second, whether you will take maybe 30 minutes or an hour doing it. Scripting allows you to just use Python for small tasks that you might face on your workplace. So for example, scripting can be something that people like accountants, lawyers, students, anybody can learn how to do scripting with Python because it will just improve their life. They don't have to become a developer, they don't have to be a programmer, but they can just learn a little bit so they can automate the boring office work stuff. And this is something where Python shines a lot. Having said that, how can you start learning Python? Well, on this video, we are launching a free Python course for absolute beginners where we are doing to do some of these automation of boring work. In the case of the course that we just uploaded, we are going to go to websites that offer jobs and we are going to take those jobs and we're going to put them on an Excel sheet for more organization. It's going to be a simple project where you're going to learn how to extract data from different websites and how to put them all inside of an Excel. Thank you for watching. Let me know what you think of this video. I hope that you go and take our free course. It's free. As always, don't forget to be happy. Don't forget to eat kimchi. And that's it. Thank you. Bye-bye. 사랑해요. 감사합니다. 안녕하세요. Today we're going to learn why a programming language like Python is slower than a programming language like C. By the way, I said slower. I didn't say slow. Slower. All programming languages are very fast, okay? They do things fast in our computer, faster than our brains can do it. So they're all fast. Some of them are slower. It doesn't mean they're slow. Computers do not understand humans. Computers speak zeros and ones. Now, humans, we speak code.
The main source of nutrition.
Programming languages. So we say, for example, if, else, function, variable. We do all that stuff, all right? So as you can see, we speak different languages. Code is here, zeros and ones are here. Two different languages. Now, there has to be a way of translating if, else, function, whatever, to zeros and ones. That process in the middle is called compilation or interpretation. Let me give you an example of interpretation and an example of compilation. So right now I'm in Turkey. Here they speak Turkish. I speak English. So I don't understand them. If I'm walking down the street and some Turkish person comes to me and they start speaking, I wouldn't know. What interpretation would do is that I will have literally my friend here, an interpreter that will be speaking to my ear and translating everything to English.
Yes, sir.
So I am getting some Turkish message here and my friend is immediately translating everything into English to my ear. That is interpretation. It happens in real time. Now, what is compilation? Compilation doesn't happen in real time. Compilation, first my friend will listen to them, and then once my friend understands the sentences, once my friend understands what they mean, my friend will translate the entire message to me. That is compilation versus interpretation. One of them, interpretation, is done in real time, and the other one is done not in real time. That's what makes a programming language slower and faster. For example, Python is interpreted and C is compiled. So on Python, there is always a person here speaking to the computer the zeros and the ones that he needs to get for every line. And that could be slow. That could be a slow process because there is always a middleman in the middle between your Python code and the zeros and ones. Now, when you work with something like C, C is compiled. That means that after you finish your program, you're going to press compile. The compiler will translate all your code into zeros and ones, and then you will be able to open your program. And of course, it will be faster because there is no middleman there. Your code will become zeros and ones immediately. And when you open the program, it will be zeros and ones. There is no middleman there. Now, another example of this, of why the difference between interpretation versus compilation. If my friend is my interpreter right here, and the Turkish person, maybe he speaks a word that my friend doesn't know, my friend will say, "Oop, sorry, I don't know." And then we're gonna be lost, right? That would be interpretation. Now, if it was compilation, and that Turkish person speaks to my friend some word he doesn't know, my friend will stop it and say like, "Hey, I don't know that word. Change the word because I need to translate that and I don't understand that word." That will be the same thing in compilation and interpretation when we have errors, for example. On Python, for example, or even JavaScript, because it's an interpreted language and it happens in real time, my code might have some errors and I might don't know about these errors until they happen. And that is not good at all. I want to know about my errors before they happen so I can fix them. But because it's interpreted, it will be real time. Now, if it's compiled, for example, when you have a mistake on C or any compiled language, and you try to compile your program, C will tell you, "Wait, 1 second, hold on, that doesn't work. I don't understand that, fix it." So you know that once you compile your software using the C compiler, for example, you know that that code doesn't have errors because the compiler approved it, basically. Of course, if you have an interpreter, there is a middleman. If you don't, you have all the power of the zeros and ones, and you can access even deeper parts of the computers without a middleman that might be a little bit slow. So that's it. I know I made big generalizations on this video. If you are already a programmer and you're experimented and you like the theory, then I know you're gonna disagree with some things that I said, but I allow myself to generalize because that's easy to explain concepts. I know sometimes you can make Python a compiled language. There are ways of doing that, but generally Python is interpreted and C is compiled. All right? Thank you for watching. I hope that you understood a little bit better about how we communicate with computers, and I hope that you like my example of my Turkish and my translator. Let me know what you think. Let me know if you like this video. Share it with your friends, and don't worry about speed. Really, it's not a big deal to choose the fastest programming language in the world. Not a big deal. That's it. Thank you very much. Thank you for watching. See you in the next one. Eat kimchi, be happy, and bye-bye. 안녕하십니까, 니콜라스입니다. Today I am going to talk about the most popular programming language in the world. This programming language is JavaScript. Even if you hate it or you love it, there's nothing we can do. JavaScript is the most popular one. Now, JavaScript is not only a language that we use to make websites with React or Vue.js. There is so much more that you can do with JavaScript, especially if you are a designer or a creative artist or a media person or a web publisher. There is so much more than you can do with JavaScript, and that's why on this video I am going to talk about the other uses of JavaScript apart from website making. First, you can make hybrid apps or cross-platform apps. I know you heard about hybrid apps before and cross-platform apps on this channel, so we're not going to talk too much about that, but if you want to make hybrid apps with JavaScript, look into something called Ionic, or if you want to build some cross-platform apps, look into something called React Native. Hybrid technology is used by Amazon, for example. Their iOS and Android application is based on web and hybrid views. Also, the WeChat ecosystem is built around hybrid apps, and the React Native side, people like Discord, Tencent, Pinterest, and some parts of Facebook and Instagram are built using React Native. So if you want to be an app developer and you know JavaScript, you can get started right away. Number 2, desktop software for Mac, Windows, and Linux. If you want to make software for the desktop, you can do that using JavaScript and Electron. Electron takes HTML, CSS, and JavaScript, compiles it, and it will give you a Windows, Linux, or macOS software ready to install in the computer. It's an awesome tool, and many of the big projects that I think that you already use are using Electron. For example, Visual Studio Code, the most popular text editor in the world, is built using HTML, CSS, JavaScript, and Electron. Also, Slack for desktop, Skype, GitHub Desktop, and also Atom, another text editor, among hundreds of thousands of other applications. So if you want to make desktop applications that your users can install, go ahead. All you need to know is HTML, CSS, and JavaScript. Now, if you're a little bit more creative and you like video games, you can make 2D video games with JavaScript really easy. You can use things like Phaser.js or Impact.js. You can make awesome 2D video games. You don't have to write anything of the physics because those engines already come with a JavaScript physics engine, and you can use the graphic card's power of the browser. Also, using Node.js and Socket.io, you can make these 2D video games interactive and multiplayer. There is one really good example of a multiplayer 2D JavaScript video game called Wanderers.io. Go check it out. It's real-time multiplayer 2D strategy game using only JavaScript. Amazing. Now, this is the part that excites me the most. 3D, VR, and AR stuff. Using, for example, 3JS, you can build awesome 3D video games running on the browser. You can create maybe really cool interactive websites for maybe advertising, portfolios, e-commerce, or just crazy 3D artistic experiments. For example, the band Arcade Fire has a couple of video clips that are on the browser. So with your camera, you can interact with the video clip, or with the mouse, you can even modify the way the video changes. And they use geolocation, they use Canvas, they use JavaScript, they use WebGL, they use so many things to make like a more immersive experience of the video clip, but on the browser. Heraclos is also a beautiful 3JS video game that combines sound, video, textures, and story all on the browser. It looks amazing, it's really, really beautiful, and it's all done with JavaScript. For example, you could also make a really interesting and interactive e-commerce website to sell some stuff, but combined with 3D. The best example I can think of is something called Campo alle Comete, which is like Italian winery. But when you go to the website, it looks almost like a video game and you don't realize that they are selling you wine. It's a really nice experience when you want to buy something. Using A-Frame or ARJS, you can also build websites that use the camera and sensors of the device to build virtual reality or augmented reality websites. You can make VR video games on the browser using AR that connect, for example, to the Oculus so that your users can play on the browser. Or you can make a website, for example, a shopping mall that shows the users directions using AR, everything running on a website without having to download any app. Also, very few people know this, but you can do machine learning on the browser. For example, you can make a 2D or 3D video game and you can use TensorFlow.js to maybe give the enemies actual artificial intelligence. That is really, really mind-blowing. And that's it. As you can see, there is so much more than you can do with JavaScript apart from just boring websites. You can make applications, desktop software, video games, 3D experiences, VR, AR websites. The possibilities are endless. If you are a JavaScript developer already, I hope that I inspire you to go and build your own video game or desktop app. If you are not a JavaScript developer, but you want to learn, then go to our website. We have a free JavaScript course for absolute beginners, so you can get started learning JavaScript and you can build amazing, crazy things like the ones I showed you on this video. Thank you so much for all your comments in the Golang video. I really, really appreciate it. I'm already working on the course, and that's it. Thank you so much. As always, don't forget to be happy. Don't forget to go build amazing, beautiful things. Don't forget to eat kimchi. That's it. 사랑해요. 감사합니다. 안녕하십니까? 니콜라스입니다. Today we're going to talk about how we can become better programmers by changing the way that we see mistakes and errors in our code. A good programmer is not a programmer that doesn't do any mistakes or that always writes the perfect code without any syntax errors. That is not what a good programmer is, okay? That shouldn't discourage you from becoming a programmer. If you make many mistakes, you shouldn't feel like, maybe this is not for me. No. That is not what a good programmer is. What a good programmer is a programmer that makes errors and learns and grows from those mistakes. If you make a mistake and you grow from it, that's when you become a good programmer. Okay? So it doesn't mean that making mistakes is bad and we should try to never make any mistakes. No. We should learn from our mistakes and we should try to never make the same mistake twice. That's how we become a good programmer. Okay? So, tip number 1 of mindset change when we see an error in our screen. We shouldn't remove ourselves from the problem. And what that means is that I've seen people sometimes, and including myself, that when I see an error on the screen of some program that I made, I think to myself, and I know many people think to themselves, and they show it on the comments on my courses, and they say, oh, the code doesn't work, as if it's something external from them. So they say, the code is not working, as if the computer or the code have a problem. And what I say to this is actually no, we made that mistake. The code is not working because of me. So I should take ownership of that mistake. I should say, I caused that problem. And when I say that, I now can fix the problem. If you are the cause of the problem, then also you can be the solution of that problem. Okay? But if we just leave all responsibility behind and we say, oh, the code doesn't work, like the code over there should be working, but it's not. No. My code is not working because of me, okay? So we need to own our mistakes. Tip number 2 is we should stop trying to fix errors. And I know that sounds crazy for me to say. Maybe you are saying like, what? We shouldn't fix an error? No, what I'm saying is we should understand where the errors come from, okay? If you're just trying to fix errors whenever they happen, you are just a fireman trying to put out fires. Okay? But the fire is going to come back again eventually. What we want as programmers is we need to understand why did this error happen, and if we understand the cause of the error, then in the future we are very less likely that we are going to repeat the same mistake because now we understand why the error happens. So now we know how we can fix it, but most importantly, why it happened. Because I know how it feels when we are working and we see an error and we see a red alert saying does not work, wrong code. What we want to do is just say, how can I fix it? So we go to Google, we ask our friends, we go to the Slack channel and we say, how can I fix this error? We shouldn't do that anymore. What we should do is, what is the cause of this error? And then also, if somebody asks you, how can I fix this error? What you should say is not, I'm not going to tell you how to fix it, I'm going to tell you what was the cause. If we understand the cause, we are less likely to repeat the error again. So let's try to understand the cause instead of just trying to make all the errors disappear. Number 3. It's very easy when we see an error to freak out and basically say, oh, it's not working again, what happened? And go back and look at the code and Google and ask our friends. It's very easy to do all those things, right? But you know what's easier than that? Reading the error message. And I know it sounds crazy and it's something so obvious, but even I forget to this day. When something doesn't work, I immediately go back to my code and try to find a problem with my code. Actually, if you look at the error message, most of the fixes, of the way to fix, of the source of the error, of the explanation of the error, is on the error message. So sometimes I get people that ask me, why is this error happening? And I say, just read the error message. It's literally there. They're telling you what you did wrong and they're telling you how you can fix it. So again, it's something so simple and so basic and so obvious, but we forget about it and I forget about it. I also get stressed. I also want to make the error disappear. I also want to be like, what happened? I want to go back and look at my code. Where actually, all I should do is look at the error message and read it. It might look intimidating because error messages don't look nice when you're a programmer. It's a bunch of code and then there is one line that says exactly what you need to do to fix it. So we can look at it, and if we don't be careful and we don't read them carefully, it just looks like gibberish. But it's actually something there. So let's look at the error messages a little bit more closely, because the people that make the libraries that we use, the people that make the programs that we use, they put those error messages there for a reason. They tell you how to fix it. They'll tell you where the source is. Thank you so much for watching. Let me know what you think on the comments, and please tell me, how do you deal with errors, and is there any technique, any tip that you can share with the community? Let us know on the comments. Thank you so much for watching again. I appreciate your support. I appreciate your likes. Don't forget to be happy. Don't forget to eat kimchi. 감사합니다. 사랑해요. And as always, bye-bye. 안녕하십니까. 니콜라스입니다. As you know, I am a self-taught software developer, and I believe that you don't need to go to college, you don't need to go to university to be able to become a programmer and to be able to get a job on a company. But having said that, learning to program by yourself online is not easy. There are many traps you can fall into, and there are many mistakes that you can make that will frustrate you and will make you waste time. So on this video, our first video of 2020, I want to talk about that. I want to talk about the mistakes and the traps that beginners fall into when learning to program by themselves and how you can avoid them. Mistake number 1, not building anything. Some people approach programming like they approach studying for an exam in school, where they just read a book, they take some notes, they memorize some things, and you're done. Programming is not something that you study. Programming is something that you do. It's a verb, it's an action. And if you're learning to program and you're not applying that knowledge, if you are not writing your own code, then you are just wasting your time. When you're learning to program, build projects, practice, make stuff from your own code. Don't copy your teacher's code, don't copy the book code, build things on your own. But also be careful, set realistic goals. It's okay to do a dumb project like a calculator or a small web scraper or a very tiny video game. That's also okay. The point is to always build something, create, write code. Don't just study, read, and memorize. Write, make stuff, build stuff, be a maker instead of a learner. Number 2 is not knowing when you are ready. This happens a lot to beginners because they feel like they haven't learned enough yet. They feel like still they have to take one more course, they have to read one more book, they have to watch one more lecture. They don't feel ready to go and apply for a job or to start their own company and build their own product. So how to avoid this? It's very easy. Go back to the point number 1 of this video. Build things. When you build something, your eyes and your brain see a visual representation and a result of all the knowledge that you've been accumulating in your head. And that tells your brain that you are ready. Simple. That gives you the confidence to know, hey, I built that. That means I am ready. Usually, the people that get stuck in the always learning phase, the ones that keep buying books, the ones that keep buying courses, the ones that keep reading stuff, those are the ones that are not building. If you want to measure your knowledge, if you want to know if you know, simple, go and build stuff. Mistake number 3 is going 100% into programming. When you're going to the gym, for example, you don't want to train 100% and give everything that you've got that day. Why not? Because you are gonna wake up the next day feeling like shit because everything hurts, and you are probably not gonna go to the gym that day or the next day, when the point is to go to the gym every day, to train every day. It's the same with programming. The point is to program every day. The point is to build a habit. The point is to learn every day. If you go 100% on programming and you forget your hobbies, you don't take breaks, you don't socialize, you just only programming, you are gonna burn out. And you are not gonna have fun learning, which should be the number one priority when you learn to program. The point is you should be able to have fun, and you should be able to wish to go and start programming. You should be able to be like, oh, I can't wait to go and start programming, start learning that. You should enjoy it. You need to find the balance. For me, sometimes it's an 80-20, sometimes it's a 70-30, sometimes I don't do programming at all. It just depends on the person. I'm not here to tell you which balance, but find your balance. Don't go 100%. Go your percent. Mistake number 4 is checking boxes. Programming is not about checking boxes, and some people, especially in Korea, they want to find a list or a roadmap of boxes to check. So they want to find a list that says, okay, check HTML, CSS, JavaScript, Java, and SQL. Boom, you are a programmer. But that just doesn't happen. Programming is not a list of boxes that you check. People don't know JavaScript, they don't know Python. We just work with it and kind of understand it, but there is never gonna be a box to check. You are never gonna finish learning Python. You are never gonna finish learning JavaScript. So that box right there is invisible. It's like a rainbow. Instead of having a list, make a list of projects that you want to make. So for example, make a chatbot, make a YouTube clone, or a video game. Now, if you follow that approach, the project-oriented learning, what you're gonna find out is that the moment you go and apply for a job, you are going to have a big portfolio. And that is gonna get you a job faster rather than somebody that just puts on the resume, I know JS, I know Java, and I know SQL. Portfolio and resume. The person with the portfolio will always win against the person that just has a resume that says, I know Java. Check. Number 5 is have a deadline. And this is something that applies for any kind of learning, not only programming, any kind of self-paced learning. When you do it by yourself, it's very easy to see the time just go by without seeing any results if you don't pressure yourself. Because when you don't have a deadline, you don't feel the pressure to go and study. You don't feel the pressure to go and finish something. You're there. You are studying programming, but when? Do you have a deadline? Do you have a commitment? With who? With yourself? And this is why people go to university, and this is why university works in that sense. Because in university, you have grades, you have exams, you have projects, you have the teacher telling you that you are gonna fail, and that keeps you on your toes actually studying. What you need to find out is a way of pressuring yourself. Maybe write your commitment on the wall and say, okay, July 2020, I am gonna learn Python. Or tell your friends, say, hey, if I don't learn Python by July, you can punch me in the throat. Or put it on Facebook, or put a bet, give money to somebody. I don't know. Find a way of pressuring yourself, because when you are learning by yourself, it's very easy to just, yeah, later, because you don't have a deadline. You need to find a deadline. Thank you so much for watching this video. Thank you so much for your support, for your attention, for listening to me. I really appreciate you watching. I really appreciate your comments. I really appreciate your likes, your views, your support, your subscriptions, everything. I hope that I can help you to become a better programmer. If you are making one of these mistakes, don't feel bad because I made them all, and that's what I'm talking about. I 사랑해요 you very much. Eat kimchi, and that's it. Thank you. See you on the next one. I'll talk to you soon. Bye bye. 안녕하십니까? 니콜라스입니다. Today we're going to talk about the difference between a library and a framework. And the reason why is because this is a question that you might get on your next programming job interview. So I want you to be able to answer this question because the concept is not that hard to understand, but it's very, very useful to know what the difference is between library and framework. So I'm going to give you an example of what is library, what is framework, and also what sort of contradictions exists because, of course, nothing is ever black and white, okay? Now, first, let me start by saying that both libraries and frameworks are code that somebody else wrote that we are using in our project, okay? So both external things that we use to finish things faster. The difference between library and framework lies on a very, very simple concept. Who is controlling who, okay? Are you in control of your code? Are you the one making all the choices, or are you following someone else's rules? And that basically is the whole difference between a library and a framework. Do you control the code? Do you control exactly what's happening, or are you following rules, okay? Let me give you an example. A good example of a library is jQuery. jQuery allows you to basically add interactivity to a website, right? Now this means that when I'm working on my website, when I'm working on some code, I will call jQuery when I need jQuery, okay? So if I need jQuery right now, I will call jQuery, I will use jQuery, and then I will keep going on my program. This is how we use libraries. We use libraries when we need them. And libraries are very easy to be replaced. If I change jQuery for something else, the website shouldn't break and my project shouldn't break. It shouldn't be a big deal to replace the library because it's just something that I'm calling to save some time, all right? Now, a framework is different because you, the programmer, doesn't call the framework. The framework calls your code, okay? And that's very important, and that's the whole difference between libraries and frameworks. When you work with a framework, you have to follow the framework's rules. You are not in control of your code. You don't decide what happens and how it happens. No. The framework tells you what to do. The framework tells you where to put your code if you want the framework to work. So the framework gives you rules. The framework gives you structure. Where to put your templates, yes, where to put your controllers, where to put your views. And if you follow those rules, everything will work. But you are not in control. You just follow the framework's rules. One example of a framework is the Django Web Framework. The Django Web Framework has a lot of rules and a lot of structure that you have to follow if you want everything to work correctly. For example, on the Django framework, if you want to have an admin panel, you need to write your code on the file called admin.py. If you want to change any sort of URL, you are going to have to go to the file called urls.py. And when Django starts, Django is going to look for a file called urls.py and admin.py. You are not in control of this. This is a rule that Django has. And now if you follow the rules correctly, you are going to have a website with an admin panel and with the URLs working. So as you can see, never in this scenario, I called Django. Never. I just look at the Django documentation, I follow the rules, I put my code on the right places, and Django will load those things. Everything that is a framework is because it has some rules that we must follow. Everything that is a library is because it's something that we call when we feel like it. I call a library, but a framework calls me. And that's very important and interesting distinction to make, all right? So next time you see something that says, blah, 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 library to build, blah, 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 you know that is something that you are going to call when you need it. But next time you see something that says, a framework for building whatever, you know that this is something that comes with some rules, something that comes with opinions, and something that you are going to have to cooperate with, basically. Where you are not in control, you just need to work under the framework's rules. If you go, for example, to the React.js website, on the React.js website, it says that React.js is a library. So it means that if you need to build the UI of your application, then that means that you are going to have to call React, right? In this case, we are calling React. So that would make React.js a library because we are calling it when we need a user interface. And React.js doesn't come with any sort of opinions. It doesn't come with a folder structure. It doesn't come with a component name. It doesn't come with anything. Except that React.js calls our components. So in this case, React.js could be a framework because React.js is calling your component. React.js is telling you the rules. React.js is telling you what is wrong and what is right. And when you write a component, React calls that component and shows it on the screen. So in this case, it's a very gray area, and you can Google around and see if React.js is a framework or a library. Because some people say that React.js is a library because you call it when you need it, but also React.js could be a framework because React.js calls our components, and React.js makes our components interactive, and React.js gives our components a state and props and all that. This also applies to Vue.js as well. So, does it matter if React.js is a framework or a library? It doesn't really matter because on the front end, all the lines are blurred. But it's very important that you and I know what's the difference, or at least in the theory, what's the difference between a framework and a library in case we get this question on an interview. So thank you for watching. Let me know what you think of this video. Let me know in the comments. Thank you again. Don't forget to be happy. 감사합니다. 사랑해요. Take care of yourself. Love yourself. Bye-bye. Before I go, I just wanted to let you all know that we just published our first book. This book is a React.js book for beginners. So go and check it out if you want to learn React.js. And also the people that buy the book are going to get a very sexy t-shirt with the Nomad Coders logo and with the words "Clone Startups Learn to Code" on the back. I hope you like it. If you want to learn React.js, this is 100% for you. Let me know what you think about it on the comments. Thank you for watching and bye-bye. 안녕하십니까, 니콜라스입니다. When you want to make iOS and Android applications, you usually have three options: hybrid applications, cross-platform applications, and native applications. Which one should I choose? Native? Cross-platform? Hybrid? Should I learn iOS and Android? Should I learn Flutter and React Native? Which one? Hybrid applications. Hybrid applications are just websites wrapped around a web view. A web view is a window of the browser without the navigation controls. So when you make a hybrid application, all you're doing is that you take HTML, CSS, and JavaScript, you wrap it around a web view, and you send it to the store. What I'm basically opening is a Google Chrome window without the navigation bar, with your HTML and CSS inside of it. Good things about this is that you don't need any native knowledge required to make an app. All you need is HTML, CSS, and JavaScript, which is an awesome thing. Bad thing about this is that you have to do everything by yourself. You have to do all the UI by yourself, or all the buttons, all the navigations, because you're basically making a website from scratch. Also, you do not have access to all the power of the phone. You cannot do, for example, some hardcore video processing. It will be too hard to do that on JavaScript because what you're doing is just a website. What you can do on a hybrid application is get some basic camera, geolocation, network information, some contacts, but not as much as maybe your application would like. If you want to make hybrid applications, look into something called Apache Cordova or PhoneGap. These are the services that wrap your HTML around that web view. Cross-platform applications. Cross-platform applications are basically when you write some sort of code that is not native code, but later on gets translated into code that iOS and Android can understand. For example, React Native, all you have to write is React code that gets compiled into some JavaScript code, and then iOS and Android execute that JavaScript code with their own JavaScript engine. In Flutter, you write Dart code, and that gets compiled to C, C++ that both iOS and Android can understand. And in Xamarin, which is what C# sharp, you write C# code and that gets compiled into some sort of intermediate language that iOS and Android can understand. So as you can see, you are not writing native code, but your code is eventually going to these native platforms. The good things about this method is that you only have to write your application once and you can see it in 2 platforms, which is awesome because you can reuse developer time. If I'm a React developer, I can make a React Native app very easy, for example. Also, if you're a Dart developer, you will be able to make an iOS app, Android app, and also a website, because now we have something called Flutter Web, which is nice. A very good thing of cross-platform development is that it attracts many people from many different backgrounds. Maybe a backend developer wants to make an app on React Native, maybe a Java developer, and what you get is just an amazing mix of ideas, libraries, tutorials, and just the community is great because cross-platform is a very attractive thing for developers. A bad thing is that still is not native, so still you will have some performance issues if what you need is performance. Don't get me wrong, cross-platform applications are not slow. If you use them for the right job, they are just the best solution. For example, some parts of Instagram run on React Native, but if you do need performance, those applications might be a little bit slow on that case because, as I told you, there is a translation step that might not allow you to reach into the power of the phone. Native development is basically just writing iOS code and Android code separately. So for iOS, you will learn something like Swift, and for Android, you will learn something like Java or Kotlin. Good things about this is that you have as much power as the phone has and you can use whatever API is available because there's no middleman between your code and the phone. Bad things about native development is that you will have to learn 2 separate platforms, iOS and Android. You have to learn Swift, you have to learn Java. They're both different and they do things differently. Also, you need to learn about Xcode and Android Studio, both separate software to create applications. So it's just more time consuming. But if performance is what you want, then maybe learning 2 platforms is going to pay off in the future. Like maybe making a camera app that puts a 3D. Then you're going to need all the power you can get, and the power comes from native development. That's it. Thank you for watching. I hope that you liked the review and I hope that now you can make a better choice into where and how to build your amazing iOS Android idea. On this video, I did not compare Flutter with React Native and Xamarin, but it's a video that maybe I will make because they are very different. They accomplish things in a different way. So let me know in the comments if you want me to make a video comparing Flutter, React Native, and Xamarin. 감사합니다 and see you on the next video. Bye bye. 안녕하십니까. Today we are going to talk about AI, machine learning, and deep learning. The reason why is because AI is everywhere in the news.
AI.
The government loves to put money on AI projects.
AI 벤처 기업들도
Investors love to put money on machine learning powered companies.
AI investment, AI joint venture.
And everybody's talking about deep learning algorithms. We are going to define what is AI, what is machine learning, what is deep learning. At the end, I'm going to tell you how a full stack programmer like me that doesn't like math and that doesn't really like calculus and all that can get started working with artificial intelligence and machine learning. AI is divided in 2 categories, narrow AI and general AI. Hollywood and Netflix and all the movies are in general AI. General AI is machines that do everything that humans do and better, that can do a general purpose AI, that can do anything. So it can talk, it can learn to play games, it can communicate, it can make a judgment, it can just be exactly like a human. And that is general AI. Right now in the world, in the industry, we are in a narrow AI. Narrow AI are machines that can only do one thing and one thing very well, where the focus of the machine is narrow. The applications are narrow. The machine can do one thing well and one thing only. An example of narrow AI would be, for example, the Facebook AI at finding out faces in photos. But that's it. This AI is not able to learn how to find out dogs in photos because it's narrow. It's narrow AI. It can only do one thing well and one thing only. That's where we are right now. But now we need to understand how we teach those AIs. Here is where machine learning comes. Machine learning is the way to accomplish AI. So how do machines learn? There are many categories of machine learning, but the most famous ones are two: unsupervised learning and supervised learning. Let's say that we are going to make an application that detects if a food is a hot dog or not a hot dog. If we did it in a supervised way, what we will do is that we will label what a hot dog is. Okay, a hot dog is a sausage. A hot dog is long. A hot dog has some sauce on top. A hot dog is between a bun. That is a label. We're going to label what a hot dog is. We're going to tell the machine what a hot dog is, all right? And then we're going to get millions of photos of any kind of food. We're going to put that into the machine, and the machine, based in our labels, the machine is going to say, okay, this photo has 60% chance of being a hot dog. So the machine is not thinking, the machine is just telling us in a probability way with statistics and mathematics. It's just telling us this has 95% chance of being a hot dog based on the labels that the humans gave to the machine. One example of supervised machine learning will be, for example, a music recommendation system. The user, us, will label the songs that we like. So we will tell the machine, these are the songs that I enjoy, this is the kind of beat that I enjoy, this is the kind of artist that I like. Next time a new song comes, the machine now has labeled data into what is a song that Nicolas likes. And then it will know if Nicolas has a 90% chance of liking this new song that's coming up. That is supervised learning. Humans label the data. Now, in unsupervised learning, the humans do not label the data. So for example, to do this hot dog app, what we are going to do is that we are going to give to the machine millions of photos of only hot dogs. We're going to give that to the machine. We're not going to give the machine any labels, and we are going to let the machine by itself figure out a label that makes a hot dog. So we're not going to tell any description of a hot dog. We're just going to give the machine a lot of hot dog photos, and the machine will figure out by itself after a lot of time and a lot of processing power and a lot of data. All right? Now, of course, I know this is just a very simple explanation. If you want this, if you like this topic, we can talk more about it in future videos. But now I need to move on to the last topic, which is deep learning. Deep learning is just a way to accomplish machine learning. Machine learning is a way to accomplish AI. Deep learning is called deep learning because it makes use of something called neural networks. Very smart scientists, very smart mathematicians and computer scientists and all that, they came up with this algorithm that works like a brain. You need a lot of data to train that, and you need a lot of processing power because it's a very long and computer intensive process. But that's it. Deep learning is a way to accomplish machine learning. Machine learning is a way to accomplish AI. All right? Now, deep learning is being used by companies, for example, like Google or Tesla, for example, because they can process and have massive amounts of data and they have massive amounts of money. So, how does a full stack programmer come up and start working with machine learning and deep learning? Well, if you want to get started in machine learning, you have to learn Python. That is like the best way to get started. If you know Python, then you can move on and look into something called TensorFlow. Thankfully, you don't have to do all these things by yourself, manually. You don't have to create the neural networks by yourself. The community has already built tons and tons of things. The most popular framework for artificial intelligence is called TensorFlow. TensorFlow is on JavaScript and Python. So those two languages are super easy to get started with, and you can get started tomorrow if you wanted to. Also, there is this thing called Brain.js. On Brain.js, they already have neural networks, deep learning algorithms, activation functions, a shit ton of things ready done for you to work with deep learning and Node.js. So if you ask me, it's an amazing thing. Like I said, the community has already built so many things. So if you're scared of math, calculus and all that, you can go and start playing around with TensorFlow or with Brain.js, and that will just give you an introduction of what is machine learning without having to take care of all the math and the calculus. Python and JavaScript, those two languages are gonna be big on machine learning. I think Python already is, it's massive, and JavaScript is starting there because it's on the web. Thank you for watching. I hope that you enjoyed this video. Let me know what you think. Let me know in the comments. Just keep in mind that this concept is for newbies and I'm not trying to be super correct and specific in all the things I say. So if you think, actually, that was wrong, just remember that I'm just trying to explain this into the easiest terms I can. Let me know what you think. Leave a like, leave a comment, subscribe, share to your friends. And as always, don't forget to eat kimchi. Bye-bye. 안녕하세요, everybody. Today we're going to talk about APIs. This video is one of the first videos of the series called Newbie Questions. Let's get started. What is an API? Why so many people talk about APIs? Why are they so important? Why does everybody have an API? Why there is a Facebook API, Instagram API? An API is just basically like this keyword right here. With this keyword, we interact with the computer. When I press a button here, a beautiful button that I can press, I press this button, something happens inside of this, something happens inside of my computer, and that shows me the text on the screen, all right? I'm interacting with the computer through the keyboard. That's how I am inputting information with the keys that they have provided. This is the only way I can interact with my computer. Now, an API is something like this. An API is how do programs interact with each other. An API is made for code to be able to interact with basically other code or other technology. An API is just basically this keyword that you make from your server and you give that keyword to the iOS application. Boom. With this key, you're going to log in. With this key, you're going to log out. With this key, you're going to upload a photo. With this key, you're going to follow somebody. And when the iOS or Android presses these keys, that is going to have an effect on the database back there on your servers far away. That is basically an API. Now, what is a REST API? What is a GraphQL API? What is a SOAP API? What is an XML API? These are just different shapes of keyboards, but they accomplish the same thing. They let programs communicate with each other. But this is not the only API that you can find. You can also find public APIs. There are weather APIs, which is a server that has the weather of everywhere in the world, and when you press the button get weather of Korea, is going to show you that weather. Also, we have Instagram API, we have Facebook APIs. Those are just keywords that your program can use to interact with those applications, with those servers. Now, APIs are designed by the people that have the server and that are making the API. So for example, some APIs, they don't allow you to do everything. Sometimes the APIs come with limitations. Sometimes you have to pay for access to the keyword. Sometimes you can only send maybe 10 requests per second. There is another kind of API, which is, for example, the web API. Web APIs are APIs made for the browser, for Google Chrome, for Firefox, for all that. And those are the same thing. The Chrome team, the Firefox team, the Safari team, they all expose buttons for you to use. Every time there is a new button popping up. And before, the API was really small, like this small. Only this part was the API. But now it's been growing, so now we have buttons, for example, that if I press this button, I can request access to the user microphone. If I press this button, I can also request access to the user camera. If I press another button, I request access to the geolocation. So those are all just buttons that you press to have some result. You don't see the internals of that job. You don't see the internals of how Chrome is getting my location. You don't see the internals of how Firefox is getting my audio. You don't do any of that. They just give you a button, and when you press it, many things happen under it, but that is not your problem. And that's why everybody loves an API. They have different purposes, but they do the same thing. They just expose buttons that then you can press with your code, and that will have some result at the end. So do you need an API? You don't need an API. It all depends on your needs. Should you build an API out of nowhere? It depends on your needs. Should you learn how to make an API? Of course you should. You can learn that in our courses or everywhere in the world. Thank you for watching. I hope that you like this tiny explanation. Let me know what other newbie questions you have. I would love to answer them on the comments or on another video. And that's it. Again, thank you, and I will see you on the next one. Don't forget, as always, eat kimchi. Bye bye. 안녕하십니까, 니콜라스입니다. And today we're going to talk about why domains cost money. When you pay for a domain, why do you have to pay for .com? And where is that money going? Where is the domain factory? And what would it take if I want to create a new domain, like for example, .kimchi? So, to understand this, first we need to learn how the domain system works. Websites are just computers connected to the internet, and the way computers find each other is by the IP address, and the IP address is just a very long series of numbers. But it will be very inefficient if instead of me saying, hey, go to nomadcolors.co, I would say something like, go to 192.168. That will be really bad. So what we came up with to fix this problem is something called the domain name system. The domain name system is basically a big phone book that has the address of your website and then their IP address. So when you go to google.com on your browser will ask that phone book, google.com IP address, and then you will be taken to that IP address. Now, the thing is, it will be very bad and inefficient if we only had one phone book, because there are millions of domain names. So actually what happens is not that there is one phone book that knows everything, but there is one phone book that knows who knows. What that means is that when you go to google.com, you're going to go and ask to the root phone book of all, and then you will say, hey, where is google.com? And they will say, we don't know where google.com is, but we know who knows. And they send you to that. That place where they send you is also another phone book, and this is called a registry. And registries are run by private companies. In this case, for example, the .com registry is run by a company called VeriSign, which is one of the biggest companies for domain names. Running a registry is not an easy job, but it's a very profitable one. A registry basically has to handle all the connections of maybe servers asking them, where is youtube.com, where is google.com, where is all the .coms. This is their job. They have to have the infrastructure, they have to have the bandwidth, they have to have the security, all that stuff. And as you can imagine, there are many tiny other books. For example, .co is another registry. .co.kr is another registry. .tv is another registry. All these are registries. Remember, registries are just books with the address and the IP. So registries are the domain factories. They are the ones with the books. .com here, .com here. They know this, but they don't sell the domains to the public. For example, if you want to buy a domain right now, you don't go to VeriSign. You go to one of the domain resellers. So GoDaddy, let's say, is a domain reseller. And when you go to GoDaddy, you pay them a little bit more of what that .com domain cost. For example, in the case of VeriSign, .com domain costs 7.5 from them. But if you go right now to GoDaddy or whatever other company, you're gonna pay more than $7.5. This is because the people that you're buying the domain from are the middleman, and they handle the users, the password, the support, the renewing, all that stuff. They handle that, and that's what you have to pay them. So for example, if you buy a .com domain from me, you will pay me, let's say, $30. I take $30, I thank you very much, and I pay 7.5 to VeriSign, and VeriSign will add your domain to the list. Now, how can I create my own registry? Because maybe I want to have a new domain and I want to say, you know what? I want to sell .kimchi domains. The way you can create your own domain and the way you can run your own registry is by applying to the ICANN. The ICANN is an organization that handles all these domain things, and they are the ones that sort of hold the key of the big and main root domain. So for example, if I say, hey, can you please put me there in the .kimchi? So if somebody asks you .kimchi, then you point them to me. This is the ICANN, and the application cost $185,000. And you need to prove that this domain will improve the internet. You also need to prove that you have the technology, you have the customer support, you have the infrastructure, and you have the money to be able to support questions to your registry, because having a registry is not an easy job. As I said, you're going to have a lot of questions of people asking you, where is I love that kimchi, where is eat kimchi? These things cost money. But the thing is that once you have your own registry, you can do almost whatever you want with the domain. You can choose to sell them or maybe not sell them. So for example, I can say, I will only sell that kimchi domains if you are a Hanguk Saram and you enjoy kimchi. That could be my choice. Or for example, some people have domains like that New York City, that NYC, and they can say, yo, only people that live here can buy this domain. So send me a copy of your address and you will be able to buy this domain. It's very, very interesting, this domain thing also, because it's a very, very good business. Like I said, the .com domain is run by a company called VeriSign, and VeriSign is very, very profitable. They also run the domain .tv. The domain .tv is assigned to the country of Tuvalu. But because they have a deal, VeriSign is the one keeping the registry of the .tv domain, and thanks to this, Tuvalu is getting $2 million a year only on royalties from the .tv domain. And that's like 10% of their whole income. So it's a very, very good business. This is all very, very public. You can go to the website and you can see exactly who runs the domain .academy, who runs the domain .sexy, because now anybody can apply. Because the ICANN opened applications long time ago, and now you can apply for any domain you want. There is .sexy, .baby, .academy, .consultant, .whatever. And you can go and see exactly who is the one running what. So, very interesting stuff, but now you know. The domain factory is the registry. A registry is just a phone book. If you want to become one of those phone books, you have to pay a lot of money and you have to have the infrastructure. But it is a very, very good business, and that's why they keep doing it, and there are even more. Remember, when you pay for a domain name, you are not paying directly to the registry. You are paying for the middleman. The middleman is the one handling the contract with you, the renewal, the credit card processing, and all that stuff. Okay? That's it for this video. Let me know what you think on the comments. Thank you so much for watching, your support, your comments, your likes, and for being here and listening to what I have to say. Don't forget to be happy. Don't forget to eat kimchi. 감사합니다. 사랑해요. Bye bye. 안녕하십니까, 니콜라스입니다. Today we are going to talk about serverless. What is it? What are the good parts? What are the bad parts? And who should be using it? Serverless is changing the way that we build applications and how we design backends. But there seems to be some confusion around what serverless actually is. And this is because of the name. Serverless literally means without a server. So people think that serverless means backends without servers. And that would be impossible because you still need a server. The code has to go somewhere. So serverless doesn't mean backends without servers. It actually means something more like backends without managing your own servers. It's longer and it doesn't sound so sexy. So that's why I guess they chose serverless. To understand the problems that serverless solves, first we need to understand how we used to deploy applications before. You had to go to the store and buy your own server and put it in your living room and plug it in by yourself. And this meant that you had to manage the software and the hardware of the server. So if, for example, your house had a problem with the energy, your server was down. Or if somebody unplugged the cable, your website just went dead. Or if your website was too popular and you had too many users and the memory of your server wasn't big enough, you had to run to the store and buy a memory and put it in your server. You had to do it all manually by yourself in your living room. Then on the 2000s, Amazon came with a product called EC2, Elastic Compute Cloud. And now, instead of having a server in your living room, you can just pay Amazon and rent a space on a server that they control and that they take care of. So now you don't have to worry about anybody plugging out the cable or the energy going down or your server not being big enough, because with Amazon, you can just pay for more storage and they will just add more storage, they will add more memory to your server. We are renting a space on a server, and Amazon or Google or Microsoft, they are the ones keeping the lights on and taking care of all the hardware related issues. But still, we need to manage the software of our server. We are just renting an empty server somewhere. We have to put the software on that server. And managing software can be very challenging because you need to keep up with the OS updates or security patches or database backups or failure recovery systems or many things that come with managing server software. And this is when serverless comes in. With serverless, you don't upload a backend to a server. With serverless, you break your backend into small little functions and you upload those functions to a server that you don't control on something, for example, like AWS Lambda. And this is the big difference about serverless and non-serverless. On non-serverless, your server is always on, 24/7, ready to answer for requests. On serverless, the functions you upload are sleeping. And the moment that they get a request, AWS, for example, will wake the function up. Yes, the function will wake up, the function will do the job, and then the function will go to sleep again. And that is the revolutionary concept about serverless, that it doesn't have to be on 24/7. And that makes it really cheap. On traditional servers, if, for example, you have 0 users or 100 users, you are still paying rent. On serverless, you only pay for an execution of your function. This means that if you get a request and your function wakes up, you start paying. If the function finishes and the function goes to sleep again, you stop paying. And this makes it really cheap. For example, the AWS Lambda prices are incredibly cheap. You can get 1 million executions for only 20 cents. That's insane. This also allows you to scale better, because that means that if you get a lot of users, for example, suddenly you have 1,000 users, what AWS will do is that it will just wake up 1,000 copies of the same function, and once those users are gone, those functions will go to sleep and you are not going to have to pay more, and the performance of your website is not going to be affected, because if you get more users, you create more functions, and it keeps going like that. So, what are the not so good parts about serverless? And there are two, in my opinion. The first one is called cold starts. Like I said, your functions are going to be asleep. And that means that when you get a request, there has to be some time, a little bit of time, that we're gonna take for the function to wake up and start working. And this can take a little bit of time, not so much, but a little bit. It will take longer than in a normal server, because a normal server is always on and ready to go. A serverless function is not on all the time, it's asleep, and it has to wake up to start working. And that can take milliseconds. It's not very slow, it's just milliseconds, but some companies really care about milliseconds, so maybe serverless wouldn't be a good fit for them. Having said that, AWS Lambda, for example, has many ways of knowing which function is popular, so it doesn't go to sleep completely and it keeps it a little bit ready to reply in case it gets more users. So it isn't a big deal, but it can still add some milliseconds to the time your server answers. The number two thing not so good about serverless is that basically you are marrying your cloud provider. If, for example, you deploy a serverless backend to AWS, you are basically marrying AWS. And if you have a fight with AWS, you cannot just take your functions and go to a different cloud provider, because migrating from serverless provider to serverless providing, it's not an easy process. It's easier if you just rent a server space on AWS and you want to go to a server space on Google Cloud. But serverless wise, the company has different ways of doing things, so migrating will be a little bit more painful. The architecture of an application will be changed when you work on serverless, because you need to get into a new mindset of you don't control your server anymore. But once you know how to work with that, and once you figure out ways of doing that, then it's very rewarding. So, who should work with serverless? I will recommend serverless to anybody that has a side project or a company that is starting and is working and trying to get a prototype out as soon as possible. Serverless allows you to work on the code and not to worry on the configuration, and it's really easy to get an idea out there using serverless. If you basically don't want to spend so much time configuring servers and caring about all that stuff, then serverless is the way. Serverless is a trade-off. You can finish products faster, configure less, and pay less because it's super cheap, but you will lose control over your server and you have to modify the architecture. As always, serverless is not going to replace the traditional way of doing backends, but it's nice to have more tools as full stacks to finish the products faster. If you want to get started with serverless, go and check out the awesome serverless framework at serverless.com or AWS Lambda, Google Cloud Functions, Apex, or Terraform. These are the ones that I've been looking at, and I'm very interested in serverless because I really like the fact that I don't have to pay anything to put my code somewhere. So that's it for this video. Let me know what you think of serverless. Are you going to try it? Have you tried it? What are you doing with it? I'm very interested in serverless myself, and I hope I can build something with it soon. Thank you for watching. Leave a like, leave a comment, tell your friends, and as always, don't forget to be happy. Don't forget to eat kimchi. 감사합니다. 사랑해요, and bye bye.